Hello there, my name is GlslViewer. I'm the author of GlslViewer, and GlslViewer is basically an engine to make and code your own shaders. It's like a sandbox for shaders on asteroids. So you can like do 2D shaders or 3D shaders. I have a whole tutorial and a class about it. But what I'm very excited is that I have to integrate GlslViewer to Blender as an add-on. And it runs as a custom render engine. And today I want to show you how you can compile it, because the more people compile it and try it, the more we can polish it and transform it into a proper add-on. Let's go to the github.com patricio/GlslViewer. You're in the GlslViewer page, you go to the wiki, and in the wiki you will find that there is a lot of like compilations options. That you will find 3 operating systems, and also you can do a web assembly module or a blended add-on, which is what we want to do today. So first you need to satisfy the dependencies for your operating system, which basically sends you to these guys over here. I'm running Linux, so I already did this, but I will follow the instructions here. If you're in Mac, the same, but only the step number 1. And in the same with Windows, only step number 1, installing the dependencies. Later, you have 2 options here. So I try to be the simplest way is just to add clone GlslViewer inside your add-ons repository, into add-ons folder. Today we're gonna go through an alternative way of doing this, which is on Visual Studio, downloading some extensions that will install your add-on, this add-on that we're compiling for you automatically. So I think that this is kind of like a good alternative way for today. It's a little more pro, and it does a little things for you. And if you want to develop and help to the project, it's a great case. So the first thing I'm gonna do, I'm gonna go to my desktop. This is how I usually install it. I clone GitHub patricio/GlslViewer recursively because we want to do it fast. I'm asking to not clone the entire folder, but just like the latest updates. So it has a depth of 1. This will make the process hopefully slightly faster. So, but this part, it takes a while. Ta-da, done. So the next step, so here is GlslViewer, is gonna be enter into GlslViewer. Well, this thing is showing all gibberish. By installing recursively, we already did this part. So the next is building. Let me move this aside. Making the build folder. Enter into the cp folder, and then in order to run inside Blender, we need to create some Python bindings. So this will have, and here is where it diverges from the rest. We will copy this. We will put it here, and we're telling that please compile it with Python bindings. So it runs, goes through this process, and then we type make. Now it's compiling. So we just finished compiling Vera, which is a C++ framework that I work. Then it compiles GlslViewer, and now it's compiling the Python bindings. We are done. So usually, and this is the different way. At this point, let's try it. If we are here, you will see that there is the binary that creates for GlslViewer, and also it creates this like Python GlslViewer. It will have a different name on our operating system. What we are searching is that here is a 3.10, which means that it's compiled against Python 3.10, which is what Blender 3.4.1 is running. So let's give it a try that this is working. GlslViewer is launched. This is the GlslViewer that we know. And now the next step is going to be opening and running this in Blender. So for this I'm gonna go to code, to Visual Code, and in Visual Code I'm loading the project. So here in the terminal you will see that we are in that folder, and we're gonna go to extensions. You're gonna install Blender. If you took Blender, you will see that I have this Blender development in VS Code installed. And the nice thing about this is that it will run Blender with the add-on already installed. Alternatively, you can follow that wiki and just clone and create the folder there, the GlslViewer folder inside your add-ons folder, Blender's add-ons folder for you. But you know, I'm showing an alternative method. So here I'm gonna tap Ctrl+Shift+P. It's gonna appear the commands that Blender allows have, and after installing that extension, you can do Blender, and then you hit basically start, and then it's gonna ask you what version of Blender. I already put mine, and then you run it, and here we are. If you go to preferences and you type GlslViewer, you will see that this is already installed. It's in the latest version. Everything is looking fine. So the next things we do is go to Engine, switch to GlslViewer. Here's gonna be the configurations, and it's gonna mention that it's gonna be using these vertex shaders and these fragment shaders. It's gonna be using one shader for everything. I have a whole series of tutorials, and you can go to the documentation online of GlslViewer about how GlslViewer fork different versions of the shaders for different materials and different cases. That's basically how all the materials can be combined in one single Uber shader. So the next step here is hitting this, and you can see here that this is working. There's some pretty colors there. Let's go to the scripting. Let's do the same thing. And here, if you will see that there was created a main frag and a vert frag. So here is so let's make this a specific color. Let's make this red. This is RGB. So so here it is. You are now ready to run real-time live coding shaders inside Blender, and I found this very powerful and fun. Let's put the vertex position or the UV space, the UV coordinates. Yes, there you go. And a couple of things. You can show the cube map or turn it on and off. Let me show you some options I have. For example, I did one without. Let me show you this first. So if you don't have geometry, you will Control X. You will do basically a 2D shader on the whole scene. I have a couple of examples I have been playing with. This is a whole ray margin scene. Save the changes before you close. No, we don't want to do that. So there's no geometry. We run this and it's not working. Oh, because I moved all the folders. Okay. Is everything broken? PBR? No. Okay, so this one is I'm using Lygia's PBR shaders functions. So and here you can see how the floor, the plane, which is the geometry for this guy, it gets separated from the dragon, which is this one, and it would compile this. So basically we can have two different materials for the same. And all this shader is model here. So if we want to change the properties and make the dragon more metallic or fully metallic, we change this here. For that, we will need to have an albedo of 1. So you can see here that this is a fully metallic. We can also use 0. We're using the clear code. So let's use the PBR material. So let's run this with anti-aliasing. It's gonna be a little more smooth, but the colors are very nice. Yeah, let's make it metallic again, or change the roughness to very few. So there you have it. Let me see if I can show you other ones. You have full access to also the different buffers. So in this case, I'm just creating a simple geometry. I'm lighting it in a simple way. This is the vertex here. The fragment is here. So I'm doing a super simple shading, but then I'm using the post-processing buffer of GlslViewer to do kind of like a post-processing effect. Couple of things to notice is that, where is the light? That the light here is going to modify this scene. So this is changing the lighting. Probably, if it's giving you weird numbers, probably is the rotation, but yeah, now it's accurate. So now you can change this, change the position, change the lighting. What else? It will load textures for you. Yeah, I changed a couple of folders, the address, so some of the things are like broken temporarily. In my side, it's yeah. A couple of things is that let's go back to this one. That this scene is fully reactive, so a lot of things has been ironed out so far. More things probably need to, but you will have shadows in real time and stuff like that. And then when you're ready, you hit render image, and it will render an image for you. So this is a fix I need to do. I'm having problems with the. This is actually it needs to go do a proper exporting gamma space. The lights are also matching the skybox. So in this example, I'm changing the position of the sky and the light, and that is creating a sky map that match it, so you can see how the lighting change conform to day. Also, is hooked to the camera. I'm putting FXSAA is an anti-aliasing. So now when the day is going down, you can see that the tone is more orange and the skybox match. Anyway, this was a way too long of a video, but I hope you enjoyed it. You get excited about being able to script your own shaders inside Blender. Hopefully you compile it, you run it, and share feedback. And if you're in Windows, I'm particularly would be particularly helpful if you help me to send me the compiles binaries, so I can put all make a bundle of all of the operating systems in a single Blender add-on that everybody can use. So that's all. Have a great weekend or week or whenever you're seeing this, and give it a try. Let me know how it goes. Thank you.